Welcome to FM A0146 Basic Mathematics. We are going to look at chapter 1.1 real numbers. In these chapters, we are going to cover the types of numbers in our real number and how to represent the numbers in the real number line, interval, or the set description. Okay, so the bigger picture of our types of number actually is start from complex number, which can represent by a C, where we write our complex number into two components. One is x plus iy, where our I actually is called pure imaginary. Okay, how these imaginary numbers coming from is you get your square root uh, minus 1, and then we have our pure real number which represent by r. Okay, in this real number we have one group of people is called rational numbers, which represent by a q, which you can write the q into the form of p over q, where your pq are the z over here for temporary, you accept it as an integer, where your q cannot be 0. Okay, now what is integer? Integer is a whole number which is there is without decimal point. Inside this rational number, you have three different category. The first category we call it as integer. Integer, as I said just now, as a whole number is 0, 1, -5, which don't have a decimal point. Okay, how about some numbers with a decimal point, which are a rational number such as 1 over 3. Although if you see over here, 1 over 3, if you written as a decimal, it will become 0.333, where the 3 itself is repeating. So any decimal numbers with a repeating decimal, it is a rational number. Another simple one is let's say we have a 22 over is 2 over 3. 2 over 3 is 0.6666, and then the 6 is keep on repeating. And then we have another type of decimal point which is called terminating decimal point, where the example such as is 0.25. Actually these numbers we can rewrite back as 1 over 4. Okay, and we have another group of the people to fulfill our pure real number is irrational number. Over here we write as an q bar. The bar at the top here indicating the meaning of not. So means is this is not rational number, so it is called irrational number. So our irrational number not say is have a limited edition, but they have a normally is quite a special types is like exponent, pi, cert 3, cert 5, cert 10. Okay, but let's say we have a cert 4. Cert 4 is not an irrational number because cert 4 is equals to 2, where 2 is an integer. Okay, now and then maybe some of you notice the pi. Why pi is an irrational number actually is 3.141 something. And maybe during your school time, some of you have the opportunity to learn about pi. Your teacher will tell you that the pi, we always approximate it as an 22 over 7. So although you write as an equal, but actually this one is approximation. So actually if you look at it, pi actually we have the value is 3.14, and the numbers at the back of this are non-repeated, so that's why it is fall into an irrational number. Okay, and as we just now we already mentioned integer. Okay, so integer is any number which a whole number, and this integer number is going to separated into three part. The first one is zero. Okay, if you look at zero in this subject, we define zero as a neutral. It well means that it is not a positive or this is not a negative numbers. Okay, zero is a neutral number. So because of a zero is a neutral number, so we're going to separate our whole set of integer into two. One is called positive integer, another one is called negative integer. And how we represent our positive integer in the notation of z. And if you notice on the top right hand side there is a cross over here, this one is mean is a positive integer, and over here there is a negative sign, so this one is a negative integer, means that actually z is representing an integer. Okay, at the same time, a positive integer is also called as a natural number, or some of the books or some of the information saying that is natural numbers, they call it as a counting number. Why it is called as a counting number? Because you can count by your finger. Okay, people will ask you how many fingers you have. Let's say you have 10 fingers, and then or you can show them by bending your fingers one, two, three. Okay, and that's why if you notice that is by using our hand, it's quite difficult to show zero. Okay, if you all bend your hand, bend your finger to make it become a feet, it will be, you can say it is a zero, but some others people thought that is a five. So naturally we don't have zero. Okay, and it progress by time we introduce zero. So over here when we set natural number represent as an n, or we can call it as a counting number, which is you count by your finger. Okay, and we have another one type of number is called whole number, represent by w, where this w is the combination of our zero and with our natural number is our whole number. Okay, and if a number it is not integer, so it become non-integer. So for example, all the decimal point, okay, so let's say you have 1 over 3, you have 1 over 2, all of these are non-integer. Okay, or even pi. Okay, pi is not, definitely is not an integer because it is an irrational number. Okay, and if you look at over here, okay, the biggest picture is always is an r. Okay, so our set q, or means is our set of our rational number is a subset of our pure real number. Why? The other one part is belongs to irrational number, and then in our rational number consists of our integer, and then is our whole number, and the smallest over here actually is an integer. Okay. Okay, so let us look at the first example. Classify the set of numbers. Over here we have 1, 2, 3. Okay, negative 1, 0, 1 over 3, exponent 1, set 3, and then 27 root 3. And then they ask you to classify whether they are as a natural, integer, or is an rational number. Okay, so we just tackle it. Okay, we just tackle it. We just classify them from the biggest one is a rational number, where rational number is any number can written as p over q. Okay, so any numbers can write as a p over q is our rational number. So then we look at it, negative 1, we can write as negative 1 over 1. 0 also can be write as 0 over 1. 1 over 3 is already in a fraction, okay? And exponent, we already know that it is not, because it actually the number is 2.1718 something. And third 3 actually is 1.6 something, I think so. Okay, and now 27 power of 1 over 3 actually is equals to 3. So this one actually is a rational number, because we can write as 3 over 1. So if you look at it, the four candidate from the out of 6 candidates, only 4 of them are rational number. Then at the same time, we already know irrational number is our e and our third trait. And we know that is an integer or a natural number must be a rational number. So these two we are no need to consider. So now we only have 4 candidates. These 4 candidates, who are the one are integer. So integer is without fraction. So we first thing we kill our 1 over 3 over here. So we have only 3 candidates. Natural numbers, we already learned that is we can count by our finger. So if now you can notice that is this one is wrong, because 0 is not the number that you can count by your finger. So you only have root of 3 of the 27. Okay, now the next example, determine whether each of the following is true or false. Okay, so this one is a subset. So we recap, we have our, the biggest actually is our real number, is a subset, then it will be our quotient, then is our integer, then is our whole number, and then our natural number. So this one is true. And now 8.1212, is it a natural number? Because we know that is natural numbers is a whole number, then this one come with an decimal point. So we already know that this one definitely is not a natural number. Okay, what is this sign? Some sort like a E and a stroke over here, actually it read as a is not an element. Okay, so means that is it your 8.1212 put, are there is an is 8.1212 is an element inside your natural number or not? So that means it is not. So this one is true. Okay, 22 over 7, is it is a quotient number? It's true, because of this one is the element, okay? And this one, please don't confuse with a pi. Okay, pi is pi, 22, 7 is 22 over 7. Okay, and then the last one over here, we check over here is correct. W is a subset of Z and is a subset of a quotient number, is not or rational number. This one is irrational number, so this one is a false. The actual one is W, is a subset of our Z, and is a subset of our rational number. Okay, now we look at how to represent any numbers, a set of numbers in a real number line, interval, and a set description. Okay, what is set description? So means that we have a set notation. Okay, set notation is start with a curly bracket, and we trying to telling people that is what variables we are using. The variable we are using over here is x, and then we try to define. Okay, so it actually is read as x is defined by x is in between a and b. Okay, so and it's not inclusive a and b. Okay, so this is called set description. Start with the curly bracket, and you're telling people what you want to play around. The variable you are involving here is an x. Okay, and then real number line is just, okay, is a line consists of all our numbers. In the middle is always is our 0. To the right hand side is increasing of our numbers 1 2 3, and definitely inside here you have more breakdown. Maybe it's 0 0.1 0.01. Okay, to the left hand side is our negative number. Towards the left hand side is the value is getting smaller. To the right hand side the numbers is getting larger. Okay, and in the we have the third way to represent is called interval. Okay, so interval means we using actually is bracket. Over here, if you look at it, we have two types of bracket. One is a round bracket, another one is square bracket. Okay, a round bracket, okay, is if it is a round bracket, means that it's not inclusive. Okay, if it is a closed bracket, it is called inclusive. Okay, so if you have a range, okay, if you have a domain or you have a range starting from A to B, okay, from starting from A to B, and not inclusive -2 and 100, so we are going to use a round bracket. Okay, if you want to inclusive our uh, -2 and 100, so that's why we are using square bracket. How about one part is inclusive, the other part is not inclusive? So it depends on which one you want to inclusive. If let's say we look at this example, we are inclusive our -2, so the bracket is on the -2 is a square, and the left hand side is a round bracket. For this one side is an a round, another one is a square, or is a square and a round. So we call it, you can call it as a half open or half closed. It doesn't matter. Just like when you saw a glass of water, over here is the water is half of it, you can say it's half full or half empty. So others over here is the same, either you want to say it is half open, okay, that means the other side is closed, or you want to say that this one is half closed because the other one is open, is up to you. Okay, and then this one, when you are bounded left and right, okay, so if you bounded left and right, we call it as a finite interval. And then versus we have an infinite interval, so means that the other side is consists of a negative infinity or a positive infinity. Okay, what is infinity? Okay, infinity is a number very, very small. If you have a negative infinity, it's called a number very, very small, or a positive infinity is a number very, very large. And then how large is it? We don't know. Okay, so that's why, because we don't know how large or how small is this number is, so we use negative infinity to represent this number, or we use a positive infinity to represent a very large number. Okay, so because of you don't know, okay, we don't know what is this infinity is, so we never ever use a square bracket for a for the infinity, regardless negative infinity or a positive infinity. So the other side is a number, doesn't matter. Okay, so let's say if you have an x greater than -6, okay, so means that you have a number -6 and then you want over here, so you can start from -6 until infinity, or at the same time you can say x -6, the upper bound is infinity. This one, if you less than -6, so means is -6. The value over here is less than -6, so you also can write as an x. The largest is -6. Over here is uh, negative infinity. But the thing is, if you written as x less than -6 is understood, the other version is this one, is understood. Okay, now we look at the relationship between number line, inequalities, and interval. Okay, so if we want to write as a set description, we have an A from A to B, which is not inclusive, so your interval must be a round bracket. So our number line are both are with a hole. Okay, so are with a hole. And if you are inclusive, this one is inclusive, so it's a solid dot. Okay, so comparing these two, you can notice that is with a solid dot means it's inclusive A and B. Without that means you have a hole over here. It's a circle or it's a dot. Okay, so if you have one side, so depends on which side is empty, so that means you have an hole, and or the other side. Okay, so if you have an infinity less than b, okay, so I think this one is less than b. Okay, sorry, if I say less than a, so that means this one is less than a, and less than equal, so that means you have a solid dot. And then greater than a, so from a you greater, you go to the right hand side, and greater and equal, this one is an a, so solid. Okay, so as I say, infinity never have a square bracket. Okay, now we look at the example 1.3. Write each of the following inequality using interval notation and the real number line. Okay, so although the interval notation comes first or the real number comes first, it doesn't matter because you can because they are in the two different contexts. So, and you no need to plot the scale. So what you need to do, this is a negative 3, x greater and equals to negative 3, so you have a value greater than negative 3 and it's a solid dot over here, because over here with a equal. So how we write is starting from a negative 3 and then until when? Until infinity. Okay, and for the next question is you have an x bounded by negative 10 and 1. So this is negative 10 and 1 bounded. And this one is not inclusive. So this one is a circle. This one is a solid. So how you write? Okay, so I think over here I have a wrong. This one is a square circle. This one is a round bracket. Okay, next. For here, this one you have to notice, the question has specifically telling you your x is a prime number, x is a prime number, and the value from this prime number is from 2 to 11, where your 2 and 11 is not inclusive. So we know that it's our prime number, let's say 2, 3, 5, 7, 11, 13. And it said that the numbers must be in between 2 and 11. So in between 2 and 11. And these two are not inclusive, so that's why we have a 3, 5, and 7. So how you want to plot? So you plot on your number line is 3, 5, and 7. So put a solid dot here, so you have a 3, 5, and 7. How to write in an interval notation? Because of you only have 3 elements, so we write as a curly bracket, and we put 3, 5, and 7 inside here. Okay. And how about this one? They told you that your z is an integer and is located between negative 3 and inclusive 3. So I have numbers greater than negative 3 is negative 2. Integer greater than negative 3 actually is negative 2. So I have a negative 2, negative 1, 0, 1, 2, and 3. And if you compare the same thing, but there is no limitation, or we can pre-assume this is a real number. What is the difference between these two answer is, for this one, your answer will become negative 3. This is 3. And this one is a round circle. And this one as a solid. They are not the same. Because for this one is representing any other tiny value inside negative 3 and 3 are inclusive. For this one, no. This one, because they already told you is an integer, so only this value of integer are included. So because of we only have 2 for 6, so we only list down the 6 element inside here, compared to if you have a real number, so your answer will be round bracket, -3 and 3, this is a square bracket. Okay, so then we have the last part of your 1.1 is union, intersection for the real number line, inequality and interval. Okay, so in the union or the intersection, union is an or. Okay, so A or B, so A or B. So when union means that you can take from set A or the set B. And for the this one is an intersection. Okay, so intersection A and B means that you must take from both party. So both party must fulfill, then you can just say that you have. Okay, so for example, this example 3, my set A is from -1 to 5. My set B is from -1 to 2 and inclusive 2. So the easiest way we are going to use our number line. So this is our number line, -5 to 2 inclusive. That's why here is solid. And over here, -1 to 5, then we have -1 to 5. And for union, so means that we only look at the leftmost and the rightmost. Okay, as long as in the middle they have some intercept, so means that this line actually are continuous. So then our A union B is from our leftmost is -5 to our rightmost is 5 and not inclusive because both are a circle. And then for this one intersection, okay, they are the same of the -5 until 2, -1 until 5. So now for intersection means that you must fulfill both party. When I must fulfill both parties, so I need to make sure upper line and lower line both sharing the same numbers. So over here, there is no lower line. Over here, there is no upper line. So that means I only have at negative in the region of -1 and 2, I have the both line are exist. So I have a -1 until 2. So how about when you want to put into the notation, means that this is solid, so that's why I have a square bracket. This one is solid, this one is an empty, so that's why it is a round bracket. Okay. And then example 5, given that interval from -3 to 2 and your set B is -5 until 5, but this set B, your x is an integer. Okay, so you need to, if the question didn't tell you anything, so means that we can assume it is a real number. But while it is not a real number, they will tell you that is what the type of number it is. So for the our set B is an integer, so means that uh, our set B is an integer. So represent A and B on a real number line. Hence express the following in the simplified answer using interval notation or the set form. So now put into a number line -3, 2 is quite easy. This one is a solid until 2. And then this one -5 until 5 is an integer. So I have a -5, -4, -3, -2, -1, 0, 1, 2, 3, and 4. And it's not inclusive 5 because the 5 is not inclusive. So A union B. Okay, so if you have an A union B, okay, so definitely if you look at here, okay, the leftmost, okay, the leftmost over here is -5, -4 only. And the rightmost is 3 and 4. So you have a 3 and 4. And inside here is a straight line over here. So you have a -3 and 2. Okay. So how about intersection? Okay, so if an intersection means that the upper and the lower must have the same, both sides must have a dot or have a line. Down here, no dot. Down here, no dot. Okay, this one, no dot. Okay, so over here, we have a line. Okay, a line and a few dots. But if you look at in between negative 4, negative 3 and negative 4, sorry, negative 2. Okay, in between negative 3 and negative 2, upper part here, there is nothing. So means that this part, they are not intersect. So you are only intersect negative 3, negative 2, negative 1, 0, 1, and 2. Is it fulfilled? No, because this one is a circle, this one is a solid. So that's mean you only intercepting 1, 2, 3, 4, and 5. So this answer is only curly bracket negative 3, negative 2, negative 1, 0, 1 only. 2 is not inclusive. So I only have these 5 points only. Okay, so now we look at some others example. They ask you to simplify negative infinity 5. Okay, so negative infinity 5, this means is until here is 5. Okay, it's not inclusive until here. Okay, and this one is 2 and 8. So 2 is here, 8 is here. You no need to draw according to the scale, doesn't matter. 2 and 8 inclusive 2 and exclusive 8. Okay, so over here, how we, this one is an union. So means if we only looking at the leftmost and the rightmost, and inside there is no problems because there is all a solid line. So then my answer is negative infinity. Our leftmost is negative infinity and our rightmost is an 8, not inclusive. And then how about the same question but negative infinity 5, intersection with a square, 2 and 8, not inclusive 8. So then over here there is nothing. So we look at here, starting they are intersecting is these 2 only. And if you look here, 5 is a circle, this one is a dot. So my here right hand side is a square bracket. Sorry, it's a round bracket. The left hand side, this is a solid, the down is a solid, so have a 2 with a square. Okay, so how about this one? Negative 2 to 3. Okay, so I have a negative 2 to 3. This one inclusive, this one exclusive. And greater than 0 is here, so it's not inclusive, greater than 0, and then it one intersection. So the two fulfill have a line is only here, so we have a 0 until 3, or you want to write as an set description 0, 3. Okay, now you can try these few questions. Question 1, question 2, question 3, and question 4. Then I will discuss it later.